If we're given a function that has x's and y's in them, but we need to find out what df dx, df dy, d squared f over dy dx, we will do something called partial derivatives. We will ignore or hold constant the values that we aren't differentiating and just multiply them in afterwards. So, for example, if we want to do df dx of the function above, for the first part, we will use the chain rule to differentiate cos 2x, which is minus 2 sine 2x, and multiply it by 4y. So the first part would be 8y sine 2x. If you're unfamiliar with the chain rule, it's linked in the description. You need to know how to do it. Then for the second part, we would just ignore the y squared for now and differentiate 3x squared. So that would be 6x, and then we just multiply in the y squared. If, let's say, we needed to do df dy, we would differentiate everything which is associated with the y term and ignore or hold constant the cos 2x or the 3x squared. So that would be 4 cos 2x plus this differentiated y squared would be 2y. So then 2y times 3x squared would be 6y x squared. If we wanted to find out what d squared f over dx dy was, we would simply differentiate df dx again, but in terms of y. So you're going to get this, we're just going to look at the y terms, which is 8y and minus 8y, and leave this as a constant. So that's going to be minus 8 sine 2x. And then we look at the y term here, which is going to be 2y. So 2y times 6x is 12xy. So now we have found out what df dx is, df dy, and d squared f dx dy. The crucial thing here is to not add these together, multiply them with one another. You just take the df dx and you differentiate it again to find out what the d squared f dx dy is.